Hello students, welcome to this lecture one probability. Okay, so in this lecture we'll continue probability a theoretical approach. So in our previous lecture there we have started probability a theoretical approach, and there we have studied some theoretical approach of for finding probability, and we have seen some examples. Okay, so here we in this lecture we will discuss first of all example on this topic. So in this example here we have two players, Sangeeta and Resma, play a tennis match. It is known that the probability of Sangeeta winning the match is 0.62. And what is the probability of Resma winning the match? So we need to find what is the probability of Resma winning the match. And here we have given the probability of Sangeeta winning the match is 0.62. Okay, so let us see how to solve it. So we let S and R denote the events that Sangeeta wins the match and Resma win the match respectively. So the probability of Sangeeta winning, that is probability of S, this is equal to 0.62, and this is given to us. And the probability of Resma's winning, that is probability of R, and this is equal to 1 minus probability of S. Okay, that is probability of R, that means probability of Resma's winning, this is equal to actually probability of not winning Sangeeta. Okay, so probability of R, this is equal to 1 minus probability of S. And as the events R and S are complementary, that is why we can write like this: probability of R, this is equal to 1 minus probability of S. And we have given the probability of S is equal to 0.62. Now if we put this value in this formula, then we will get the probability of Resma's winning, that is equal to 1 minus 0.62, that is equal to 0.38. Okay, so the probability of Resma's winning is 0.38. And now let us see next example. So in next example here we have Savita and Hamida are friends, and now it asks to us what is the probability that both will have different birthdays, and second the same birthday, ignoring a leap year. So here the one disclaimer, ignoring a leap year. So Savita and Hamida, they are friends, and we have asked here what is the probability that both will be different birthdays, one and the same birthday. Okay, second. So let us see how to solve this problem. So out of the two friends, one girl says Sabita's birthday can be any day of the year. So now Hamida's birthday can also be any day of 365 days in the year. Okay, so we assume that these 365 outcomes are equally likely. So here we assume these 365 outcomes are equally likely. So number one, if Hamida's birthday is different from Savita's, the number of favorable outcomes for her birthday is 365 minus 1, that is equal to 364. Okay, so if Hamida's birthday is different from Savita's birthday, then the number of favorable outcomes for her birthdays is equal to 365 minus 1, that is equal to 364. And so probability of Hamida's birthday is different from the Savita's birthday, that is equal to 364 divided by 365. Okay, so here basically we use the theoretical definition of probability, that is probability of an event E is equal to the number of outcomes favorable to the event E divided by number of total outcomes. Okay, so here the number of total outcomes 365, and here the outcomes favorable to the event by Hamida's birthday is different from the Savita's birthday is 364. Okay, so the probability of Hamida's birthday is different from Savita's birthday is equal to 364 divided by 365. Okay, and now second, probability of Savita and Hamida have the same birthday. Okay, so first of all, try to understand Sabita and Hamida have the same birthday means what? So Sabita and Hamida have the same birthday. That means not both have different birthdays. Okay, so not both have different birthdays. That means 1 minus 1 minus probability of both have different birthdays. Okay, so probability of Sabita and Hamida have the same birthday is equal to 1 minus probability of both have different birthdays, that is equal to 1 minus 364 divided by 365. Okay, so in our previous slide there we have find probability of both have different birthdays, that is equal to 364 divided by 365. Okay, so we get 1 minus 364 by 365. Here basically we using this formula probability of E bar, that means probability of Savita and Hamida have the same birthday. This is equal to 1 minus probability of E, that means 1 minus probability of both have different birthdays. Okay, so after calculating this, then you will get 365 minus 364 divided by 365, that is equal to 1 by 365. Okay, therefore probability of Sabita and Hamida have the same birthday is equal to 1 by 365. And now let us see next example. So in next example here we have, there are 40 students in class 10 of a school, of whom 25 are girls and 15 are boys. The class teacher has to select one student as a class representative. She writes the name of each student on a separate card, the cards being identical. So then she puts card in a bag and stirs them thoroughly. She then draws one card from the bag. What is the probability that the name written on the card is the name of a girl, and secondly name of a boy? Okay, so mainly in this example here we have 40 students in class 10 of a school, of whom 25 girls and 15 are boys. Okay, and for teacher has to select one student as a class representative, and here she writes the name of each student on a separate card, the cards being identical. Then she puts cards in a bag and stirs them thoroughly, and then she then draws one card from the bag. And now what is the probability that the name written on the card is the name of a girl and a name of a boy? So let us see how to solve this problem. So there are 40 students and only one name card has to be chosen. So in first question, what is the probability that the name written on the card is the name of a girl? Okay, so the number of all possible outcome is here 40, and the number of outcomes favorable for a card with the name of girl is 25. Okay, since there are 25 girls in a class, so the number of outcomes favorable for a card with the name of a girl is 25, and here the total number of all possible outcome is 40. So therefore probability of card with the name of a girl, this is equal to probability of girl, that is equal to 25 by 40. Okay, and this is equal to 5 by 8. Okay, so probability of card with name of a girl, this is equal to 5 by 8. And then second we need to find the probability of card with name of a boy. Okay, so the number of outcomes favorable for a card with the name of a boy is 15. Okay, since in class there are 15 boys. Okay, so therefore probability of card with name of a boy, this is equal to probability of boy, that is equal to 15 by 40, that is equal to 3 by 8. Okay, so here note it down. We can also determine probability of boy by taking probability of boy, this is equal to 1 minus probability of not boy, that is equal to 1 minus probability of girl. Okay, and we found the probability of girl, this is equal to 5 by 8. So this is equal to 1 minus 5 by 8, this is equal to 3 by 8. So probability of boy, this is equal to 3 by 8. And now let us see next example. So in next example here we have a box contains 3 ball, 3 blue ball, 2 white ball, sorry, not ball, marbles. So a box contains 3 blue, 2 white and 4 red marbles. If a marble is drawn at random from the box, then what is the probability that it will be white, blue and red? Okay, so let us find the probability. So saying that a marble is drawn at random is a short way of saying that all the marbles are equally likely to be drawn. Okay, so therefore the number of possible outcomes, this is equal to 3 plus 2 plus 4, that is equal to 9. Okay, and then and why this is? Because there are, the box contains 3 blue, 2 white and 4 red balls. Okay, if we now add them, then you will get number of possible outcomes, that is equal to 3 plus 2 plus 4, that is equal to 9. And here we let W denote the even the marble is white, and B denote the even the marble is blue, and R denote the even marble is red. Okay, so now number of outcomes favorable to even W is 2, and so probability of W is 2 by 9. And similarly probability of B, that is probability of getting blue marbles, this is equal to 3 by 9, since there are 3 blue balls, okay, in box. So total number of outcome is 9, and then number of outcomes favorable to the even B is 3, so therefore probability of B is equal to 3 by 9, that is equal to 1 by 3. Okay, and probability of R, this is equal to 4 by 9, since the number of outcomes favorable to the even R is 4 and total number of possible outcomes is 9. So probability of R, this is equal to 4 by 9. And note that probability of W plus probability of B plus probability of R, this is equal to actually 2 by 9 plus 1 by 3 plus 4 by 9, that is equal to 1. Okay, so now let us see next example. So in next example here we have, Harpreet tosses 2 different coins simultaneously. Say one is of rupees 1 and other of rupees 2. So what is the probability that she gets at least one head? Okay, so we need to find the probability that she gets at least one head. So we write H for head and T for tail. When 2 coins are tossed simultaneously, the possible outcomes are head, 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 tail, tail, head, and tail, tail. Which are all equally likely? So here H, H means the head up on the first coin, say 1 rupees 1, and head up on the second coin rupees 2. Similarly, H, T, this means head up on the first coin and tail off on the second coin, and so on. And the outcomes favorable to the even E, at least one head, are H, H and H, tail and tail, head. Okay, at least one head, that means H, H, T and T, H. And now, so the number of outcomes favorable to E is 3, and therefore probability of E, this is equal to number of number of outcomes favorable to E divided by total number of possible outcomes. Okay, and so probability of E, this is equal to 3 by 4. That is the probability that Harpreet gets at least one head is 3 by 4. And here note it down. You can also find probability of E as follows. Probability of E, this is equal to 1 minus probability of E bar, and this is equal to 1 minus 1 by 4, and this is equal to 3 by 4. Since probability of E bar, this is equal to probability of no head, that is equal to 1 by 4. So did you observe that in all the examples discussed so far, the number of possible outcomes in each case, in each experiment was finite. So if not, check it now. So if not, the possible number of possible outcome in each experiment finite, then check it now. So there are many experiments in which the outcome is any number between two given numbers, while in which the outcome is every point within a circle or rectangle, etc. Can you now count the number of all possible outcomes? As you know, this is not possible since there are infinitely many numbers between two given numbers, or there are infinitely many points within a circle. So the definition of theoretical probability which you have learned so far cannot be applied in the present form. So what is the way out? So to answer this, let us consider the following example. Okay, so here we'll discuss some example for answering the question. So here example 10, in a musical chair game, the person playing the music has been advised to stop playing the music at any time within 2 minutes. After she starts playing, what is the probability that the music will stop within the first half minute after starting? Okay, so let us find. So here the possible outcomes are whole numbers between 0 to 0 and 2, and this is the portion of the number line from 0 to 2 is this. Okay, and here we let E be the event that the music is stopped within the first half time. So here the outcomes favorable to E are points 1 the number line from 0 to 1 by 2, and the distance from 0 to 2 is 2, and while the distance from 0 to half is half, and since all the outcomes are equally likely, so we can argue that of the total distance of 2 and the distance favorable to E is 1 by 2. Okay, so probability of E, this is equal to distance favorable to the even E divided by total distance in which outcomes can lie. Okay, and this is equal to 1 by 2 divided by 2, and this is equal to 1 by 4. So the probability of E, this is equal to 1 by 4. And now can you now extend the idea of example 10 for finding the probability as a ratio of favorable area to the total area? Okay, so let us answer by this example. So here a missing helicopter is reported to have crashed somewhere in the rectangular region shown in figure 14.2. Okay, so here in this rectangular region, so a missing helicopter is reported to have crashed somewhere in the rectangular region shown in this figure. So what is the probability that it crashed inside the lake inside the lake in shown the figure shown in the figure? Okay, so let us find. The helicopter is equally likely to crash anywhere in the region. So area of the entire region where the helicopter can crash, this is equal to 4.5 times 9 kilometers square, that is equal to 40.5 kilometers square. Okay, and area of the lake, that is 2.5 times 3 kilometers square, that is equal to 7.5 kilometers square. And therefore probability of helicopter crash in the lake, this is equal to 7.5 divided by 40.5, and this is equal to 70 by 405, and this is equal to 5 by 27. So therefore the probability of helicopter crash in the lake is equal to 5 by 27. Okay, and let us see next example. So in next example here we have a carton consists of 100 shards, of which 88 are good, 8 have minor defects, and 4 have major defects. Jimmy, a trader, will only accept the shards which are good, but Sujatha, another trader, will only reject the shards which have major defects. One shard is drawn at random from the carton. What is the probability that it is acceptable to Jimmy? Okay, and then what is the probability that it is acceptable to Sujatha? Okay, so let us see how to solve this problem. So one shard is drawn at random from the curtain of 100 shards. Therefore, there are 100 equally likely outcomes. So the number of outcomes favorable to acceptable to Jimmy is 88, because there are 88 shards are good. Okay, and Jimmy accept only good shards. Okay, so the number of outcomes favorable to Jimmy is 88. and therefore probability of SAT is acceptable to Jimmy is 88 by 100, that is equal to 0.88. Okay, and second, what is the probability of acceptable to Sujatha? Okay, so the number of outcomes favorable to Sujatha is 88 plus 8. Why? Because Sujatha Sujatha reject the SARs which have major effects. Okay, and here we have four SARs that have major effects. Okay, so the number of outcomes favorable to Sujatha is 88 plus 8, that is equal to 96. And so probability of SAT is acceptable to Sujatha is 96 by 100, and this is equal to 0.96. Okay, and let us see next example. So in next example, here we have two dice, one blue and one gray are thrown at the same time, and write down all the possible outcomes. And what is the possibility that the sum of two numbers appearing on the top of the dice is 8, 13, and less than or equal to 12. Okay, so let us solve this problem. So here, when the blue die shows 1, the gray die could show any one of the numbers 1, 2, 3, 4, 5, 6. Okay, so the same is true when the blue die shows 2, 3, 4, 5, or 6. The possible outcomes of the experiments are listed in this table. Okay, so these are all possible outcomes. Okay, the first number in each water pair is a number appearing on the blue die, and the second number is that on the gray die. Okay, so the note that the pair 1 comma 4 here, 1 comma 4 is different from 4 comma 1. Okay, they are not equal. So the number of possible outcomes here, so possible outcomes for a one die, okay, is 6. And so the number of possible outcomes for throwing two dice, two die is 6 into 6, that is equal to 36. Okay, so the outcomes favorable to the event, the sum of the two numbers is 8, denoted by E, are 2 comma 6, 3 comma 5, 4 comma 4, 5 comma 3, 6 comma 6 comma 2, and these are all possible outcomes favorable to the event. Okay, and there is the number of outcomes favorable to even E is 5, and hence probability of E, this is equal to 5 by 36. And now, as you can see from figure 14.3, there is no outcome favorable to the even if the sum of two numbers is 13. Okay, so the probability of f is equal to 0 by 36, that is equal to 0. So probability of f is equal to 0. And now let us see the third one. So as you can see from figure 14.3, while the outcomes are favorable to the even G, sum of two numbers less than or equal to 12. So probability of G is equal to 36 by 36, that is equal to 1. Okay. So I stop here this lecture. Thank you very much to all of you.